Again, these are just sketches, they're not exact. That's an exact parabola. This one I'm going to start off by making my axis here before I even do any work. This problem is going to require a little bit more work. Here's what this is asking me. I need to find the A and the B for this, but I don't have an A and a B because this equation needs to be squared first, or FOIL. This little 2 means that it's saying that there's 2 of those, so I need to multiply x times x times 3, 3 times x, 3 times 3. So I'm going to FOIL this, and I'm going to get x squared plus 3x plus 3x plus 9. Combine those 2. And what do I? This is my A, this is my B, this is my C. Plug it into the formula, this formula, what I'm plugging it into right now, negative 6, 2 times 1, negative 6 over 2, which is negative 2. Alright, so that's my x. Nope, that's my x. So I gotta take that now. Now I have 2 choices. I can plug it back in here, which I think is a little more complicated. Or I can plug it in to my original equation. I'm going to go to the original one because in the original one, it's going to come out a little nicer. Negative 3 and a positive 3, that adds up to nothing, or 0. So y is 0. My coordinate then is negative 3, 0. So it's going to go left 3, right there. So my question to you is this going to open upward or is this going to open downward? How can you tell if you look back at the A? Is A positive or is A negative? A is positive, so it's going to go up. Like that. Yep. Number 12. Taking a look at number 12. Page 37. Here's what we have. A is 1. B is negative 4. So my formula is 4 over 2 times 1. This is going to be x. 4 over 2, which is 2. Take that 2, plug it into all the x's. So that now I can figure out what y equals. Y is equal to 2 squared minus 4 times 2 plus 3. So this is going to be 4 minus 8 plus 3. Negative 4 plus 3, which is negative 1. Take this number. That is going to be the coordinate for my vertex. 2, negative 1. Let me go ahead and draw axes here. The point is at 2, negative 1. That's 2 to the right, down 1. And the parabola is going to go up or down. Let's take a look at A. A is positive. Parabola opens up. Okay, take a look at number 13. A is negative 1. B is 6. Plug it into the formula. Negative B over 2 times negative 1. So you get negative 6 over negative 2. Positive 3. That's your x. Take this. Plug it into the x's. Here and here. So here's what I get. Now this was tricky because it has a negative up front. This negative does not go away. It's still going to be there. So here's what I get. Negative 9 plus 18 minus 5. So what do I get here? I get 9 minus 5, which is 4. So the coordinates for my vertex are 3, 4. I'll go ahead and draw my axes here. And I need to go 3 to the right. 1, 2, 3. Up 4. 1, 2, 3. That's where the vertex is. Once again, I visit the letter A because that tells me if it's positive, it's going to go up. But it's negative, so it's going to go down. And that should be enough to figure out what are the right answers. Number 15 says, based on your work on problems 3 to 14, what seems to be the direction of the parabola when A opens up? So here's what we're doing. If A is positive, it opens up. And then if a is negative, or less than 0, it opens down. In other words, positive a is going to give us this graph, negative a is going to give us this graph. Number 16, they want you to consolidate two ideas. What is a solution and what is an x-intercept? Well, they're exactly the same thing. When you have these parabolas, and say the parabola looks like this, notice that the parabola, this, never, ever, ever crosses this line. This is the x-axis. So there is no x-intercept. When there is no x-intercept, there is no solution. The solution is the x-intercept. They're exactly the same thing. They're just two words for the same number. Another scenario is, let me see if we can move this a little bit. What happens if I move this right here? Well, in that case, this parabola hits the x-intercept one time, so there's only one x-intercept. It hits the x-axis at one point. So there is one solution. What is that solution? Well, whatever point that is. So if that's like 3, then that's the x-intercept. The main concept here is not so much how to do it or what's going on. All you need to understand is this. A solution is the same thing as an x-intercept. They mean the same thing. And then what happens when there are two x-intercepts? So what happens if this thing was like this? Well, it would be crossing the x-axis at 2 points. Therefore, there would be two solutions. And we're coming down to the end, last two problems of this section. Here's what we have for number 17. It says the U.S. Naval Research Laboratory designed a giant radio telescope that had a diameter of 300 feet and a maximum depth of 44 feet. So they created this telescope that kind of looks like a parabola. And it has a depth of 44 feet and a diameter going across of 300 feet. Find the equation of this parabola. How do I find this equation? Well, pretend this is our graph here. Notice that the vertex is at 0, 0. And if this is going up 44 feet, it's going to go across 150 because there's 150 on each side. So this point right here is the point. What is this point? That's the point 150, comma 44. So here's how we do this. I know that my equation is going to be y equals some number x squared. I don't know what the rest will be, but I know that that's going to be one of the cases. So all I need to do is plug in this in here and this in here, and that'll tell me what is the number that we need to figure out for this. So it's going to be 44 equals some unknown, 150 squared. So what's 150 times 150? That's right, we guessed it. 222,500. And to get the number that goes in front here, I'm going to divide both sides by 222,500. Divide by 20,500. And that doesn't really reduce. So we're going to leave it like that. I mean, you can reduce it by 2. Let me see if that really reduces by anything else other than that. 20,500. It does reduce by 4. So it's going to give me 11 over 5,625.